Good morning, sir. Patricia Segal, Zainab and I are here today to present our findings on the bridge between Building K and A at Victoria University. Our aim throughout our unit, Basic Structural Mechanics, has been to successfully gain hands-on experience at finding the forces of real structures. This has proven to be beneficial for us as we have gained more knowledge from being able to view the structure instead of copying a given example from a worksheet. There are 12 important slides that will be spoken about by each member of the group in today's speech. I'll be starting the presentation with an introduction to our group members and who will be discussing each slide as well as Phase 3 and the overall understanding of this unit. Patricia will give a clear understanding upon her slides, which consist of Phase 2 as well as the discussion and conclusion of our report. On the other hand, we will have Zainab who will go in further details about the aim of our overall report and including her understanding of Phase 1. I'll be now passing it to Zainab in order for her to expand her knowledge of her slides.
For Phase 1, our aim was to find the density and the mass of the bridge between Building K and Building A through measuring the width, the length, and the height. For Phase 2, the aim is to find the total surface load on the beams of the bridge, and to calculate this, we'll have to calculate the dead and the live loads together. For Phase 3, the aim is to calculate the shear force and the bending moments, and in order to do that, we must evaluate the internal stresses of the main beam in the bridge. For Phase 1, our aim was to find the density and the mass of the bridge between Building K and Building A through measuring the width, the length, and the height. For Phase 2, the aim is to find the total surface load on the beams of the bridge, and to calculate this, we will have to calculate the dead load and live loads together. For Phase 3, the aim is to calculate the shear force and the bending moment, and in order to do that, we must evaluate the internal stresses of the main beam on the bridge. For Phase 1, for this project, the problem that needs solving is the mass and the density of the bridge. In order to calculate these, we first need to find the volume. Finding the volume of section proved to be an easy task as we gained this knowledge from prior units. In this specific case, the volume is found by multiplying the height, the width, and the length. It was then adjusted depending on the number of structural elements in the bridge. For example, for the slab, we needed to times the length, the width, and the height together, which gave us 16.292 meters squared. In order to find the density, we had to do some research on the density of the concrete which was used in the bridge, which we found out to be 2,320. Once these measurements are made, we can then solve the mass, which is multiplied the volume with the density, which gave us the total of 37,797.44 kilos.
Hi, I'm Patricia and I'm here to discuss with you the second phase of our analysis. For the second phase of our assignment, we were to find the total load on the bridge, as well as the reactions from each column. For this to happen accurately, we needed to do excessive research on the fundamentals of loads. From class, we gathered that loads come from a variety of circumstances, including rain, wind, and even earthquakes. For our bridge, we had to take into consideration the dead load as well as the live load. The dead load consisting of structural elements such as columns, beams, and so on, and the live load being the weight of the people who will be inevitably crossing the bridge as it is a university. Dead loads are calculated by multiplying the self-weight of the bridge by the superimposed load, and the live loads are calculated by multiplying pressure with length. In calculating the total force on the bridge, we use the formula force equals mass times gravity. The formula was easy to use as we had the mass of the bridge already and the gravity. Our total force load was 1,077.4 newtons and our distributed load was 57.3 newtons. The second part of this phase involved finding the actual loads of the columns. In total, there were 6 columns on the structure. 4 of those loads were equal in actual loads and 2 were not. The column's live loads were calculated by multiplying the pressure by the length and width of the column. This was then added to the dead load. The pressure, 5 kPa, was found in the Australian Standards Guide. Following that, it was multiplied by the number of columns involved in the equation. One column actual force was divided by 2, whilst the other ones were divided by 4. Column 1 was equal to 310 newtons and column 2 was 229 newtons. Lastly, we were to find the reactional forces from these columns. Finding this proved to be difficult for us as it was a concept we struggled with understanding. The calculations were started by drawing a force diagram so that it was easier to comprehend the direction of the forces. In addition to this, we made a few assumptions in this phase, including the force of gravity being 9.8 and the direction of the reactionary forces going upwards. Once the diagram was done, we began the calculations, multiplying the total point load by gravity and multiplying it by the length. Since the bridge was split in half, as Zainab previously mentioned, we had A being 6.6 meters and B being 10.8 meters, using these as the new lengths. To find reactionary force C, we used algebra to find the missing value. Using the equation Fy equals 0, the same applied to the following reactions and so on. Our findings for the reactions were the following. Ray equals 247 newtons, Rby equals 539 newtons, and Rcy equals 145 newtons.
For phase 3, we had to calculate the bending moment and shear force of the bridge. For this, we used the calculations that Patricia previously mentioned in order for the shear and bending moment to be correctly found. Shear stress is the force F acting as the given section divided by the cross, section A of the section, calculated in the direction of the force. Additionally, a bending moment is simply the bend that takes place in a beam due to a moment. When calculating the bending moment, the standard units are Nm and the clockwise bending is taken as a negative.
For all calculations, there are bound to be certain errors that occur throughout. In our case, we made a variety and left ourselves with plenty of room for improvement. Now that we've been reflecting on our own analysis, we have been able to see the exact areas that still need improvement. One of these is our ability to round off coherently to significant figures. It's either forgotten completely or done incorrectly. I can see that this is done throughout all of our phases. Another major issue is our lack of uncertainties. We understand the concept of uncertainties, however, we never include them in our findings. Altogether, we put in the best of our abilities, but we are still demonstrating a struggle in our end results, more often than not being completely far off the solution. As a group, we know the importance of basic structural materials in terms of our future and plan to put extra effort in order to improve. In total, we believe our findings have been somewhat accurate, despite not including uncertainties, which is a major aspect in presenting data. However, Victoria University is still able to use this data in the future if they were ever going to renovate the bridge or add any structures between the buildings or above. These findings can also be used if the university wanted to include a different type of material or build a similar bridge on another campus or between another building.
So, what have we learned in this unit? We will be discussing 2 points relating to this concept: subject matter and skills. As a subject matter, we learned how to calculate the bridge, and by using those measurements, we got the total mass and the live load of the bridge. Additionally, we had an understanding of how structures must be capable of carrying loads that they are designed for without collapsing. Most importantly, we got to learn about numbers, the limitation of measurements, and how errors or uncertainties in measurements transfer to calculations that use those measurements. At the beginning of our unit, we got to measure a real-life bridge, in our uni. Therefore, it gave us a chance to analyze the behaviors of its structural members under real load situations, expanding our skills that will be beneficial of. So, what have we learned in this unit? We will be discussing 2 points relating to this concept: subject matter and skills. As a subject matter, we learned how to calculate the bridge, and by using those measurements, we got the total mass and the live load of the bridge. Additionally, we had an understanding of how structures must be capable of carrying loads that they are designed for, without collapsing. Most importantly, we got to learn about numbers, the limitation of measurements, and how errors or uncertainties in measurements transfer to calculations that use those measurements. At the beginning of our unit, we got to measure a real-life bridge in our uni, therefore gave us a chance to analyze the behaviors of its structural members under real load situations, expanding our skills that will be beneficial for us in regards to our future professions. We learned how to measure precisely and accurately, as Zainab mentioned, as well as solving a problem that might very well happen in the work field. Working together has been a great help for us, giving us insight to collaborating with our peers. It's always interesting to hear the variety of ways how people solve the equation to what suits them and their learning needs. We gained a vital skill in understanding team effort is followed by maximum results. So trying to make sure everyone in the group understands the topic is a must. Time management has also been something gained and most importantly valued in this unit. Because of the strict timelines, in order to ensure we don't fall behind, we have to keep up to date with the phases and homework we're given. Once you fall behind in that, we learned the hard way is difficult to catch up. Adding to this, requesting feedback constantly before something is due has been so helpful to us as it gives us room to improve any errors that we've made. We appreciate the time, patience, and effort you have put into this unit teaching us. Thank you for listening, sir.